This question comes from Max, who asks, what if we created an artificial sun on Earth?
Max, buckle up, because we're about to dive into a world where humanity tries to bottle up the ultimate power source. Imagine a tiny star sitting in a lab or a desert somewhere, radiating energy like it's just another day in the cosmos. Sounds cool, until you realize stars aren't exactly gentle house pets.
Let's start with size, or rather, the lack of it. An artificial sun wouldn't need to be the size of our actual sun to be deadly. Nuclear fusion, the process that powers real stars, releases massive amounts of energy from tiny amounts of fuel. If we could replicate that here on Earth, even a ball of plasma just a few meters across could outshine the city lights of New York and possibly toast anyone standing too close. Max, it's basically the ultimate don't touch sign in physics form. Energy containment is the first big challenge. Stars are enormous because they rely on their own gravity to hold themselves together. On Earth, we don't have that luxury. Our artificial sun would need magnetic fields strong enough to suspend superheated plasma without letting it melt the lab floor or the planet underneath it. Imagine trying to hold a million-degree soup with invisible hands. That's basically what we'd be attempting. Max, your microwave at home just got jealous. Next, let's talk light and heat. Our real sun bathes Earth in 1.74 times 10 to the 17th watts of power. Even a fraction of that concentrated in a lab would vaporize oceans, melt mountains, and probably make sunglasses obsolete. Max, your tan might finally be permanent if you survive the initial setup. Seriously, controlling that much energy on a small scale is like juggling chainsaws made of molten plasma. Thrilling, but not recommended. But let's say we succeed somehow. This artificial sun could power Earth indefinitely, solving every energy crisis in seconds. All your fossil fuels? Gone. No more blackouts. Max, your phone, your fridge, even your neighbor's annoying leaf blower, powered by the fusion of hydrogen atoms. Infinite energy, but with one caveat. If containment fails, the consequences aren't just blackouts, they're global-scale disasters. Radiation is another tricky factor. A star emits not just visible light, but gamma rays, X-rays, and solar wind. Shielding ourselves from an artificial sun is not optional. Max, we'd need buildings made of neutron star-grade material or some kind of plasma-proof bubble suit just to take a casual stroll outside. And forget about pets. Your dog or cat would become instant cosmic sushi. There's also the problem of gravity, or rather, lack thereof. Real stars are massive enough to warp space-time. But our Earth-sized artificial sun wouldn't do that. Instead, it's more of a local hazard than a cosmic one. Heat, light, radiation, yes. Black holes, not unless we really mess things up. Max, the universe isn't ending here, just your city, lab, or maybe country. Imagine the societal implications. With infinite energy, wars over resources could become obsolete. Deserts could bloom. Water could be split into hydrogen and oxygen for fuel. And space travel could finally take off without worrying about fuel limitations. Max, humanity might finally achieve the energy utopia of sci-fi dreams, or turn Earth into one giant solar oven. And let's not forget maintenance. Stars burn out eventually. Artificial suns would require constant input of fuel and careful regulation of plasma conditions. One wrong tweak, and suddenly our tiny sun could overheat. Max, think of it as trying to babysit a cat that's simultaneously a miniature star. It purrs, it glows, and if you look away for 1 second, boom. In conclusion, Max, creating an artificial sun on Earth is theoretically possible, but practically terrifying. The potential benefits, limitless energy, technological leaps, solving climate change, are enormous. But the risks?
global catastrophe, radiation storms, and accidental solar barbecue. So while the idea sparks the imagination, it also reminds us why stars stay in space.
P.S. Max, maybe it's best to start small, like plasma in a tokamak, and leave the full-blown mini-star experiments to sci-fi. Or the next generation of fearless physicists with better insurance policies.